The next family we're going to look at is the cubic family, or the cubing function. The equation for that parent is y equals x cubed. So in function notation, it's just f of x equals x cubed. Let's look at the keys to graphing. Now in cubing function, we're going to start at 0, 0. This is going to be a little bit different. We're going to move over 1, and then if I cube my x of 1, I'm going to be moving up 1. So from 0, 0, I go over 1, up 1. Then if I go over 2, I'm going to be going up 2 cubed, which is 2 times 2 times 2. So over 2, up 8. Then my next value, if I went over 3, I'd end up going up 3 times 3 times 3, or 27. Now that won't fit on my graph, so I'm just going to leave it at the first 3 points. But let's look at what happens when I go left. It's a little different than a parabola. If I go left 1, that's really putting an x value of negative 1. If I put negative 1 in for x, I'll have negative 1 times negative 1, which is positive 1, and then times negative 1 again. So if I put in left 1 or negative 1, I'm going to get out negative 1 or down 1. So this goes left 1, down 1. Likewise, if I move left 2, I will be moving down 8 instead of up. So left 2, down 8. And then my third point would be left 3 and down 27. Again, that's off the chart, so we're not going to plot it. When I connect these, I should end up with a smooth curve that actually looks like half of a parabola in quadrant 1, and then it kind of twists around and makes half of an upside down parabola in quadrant 3. So it looks a little bit like a twisted parabola. So you can call it a twisted parabola if you'd like to. I tend to call it a squiggle, so that's what I'll put for my nickname. But whatever reminds you of how to draw it is fine with me. Then let's look at our domain. Domain is as you scan left to right. Now don't be confused by the graph looking like it's kind of stuck in this spot right here. It's really not. I could put in any x value. This continues to grow outward forever. So the domain of this function is actually negative infinity to infinity. And the range, as we go from bottom to top, is also negative infinity to infinity. Symmetry. If I fold this across the y-axis, it does not match up. Let's see what happens if I rotate it 180 degrees about the origin. I end up getting the same graph upside down as I did right side up. So this graph has origin symmetry, which means it is an odd function. Where is this graph increasing and decreasing? Well, remember I start at negative infinity and I scan left to right. So if I'm starting out at negative infinity, the graph is way down below and it's rising, rising, rising. It takes a little squiggle in the middle and it continues to rise, rise, rise. So this graph is actually increasing everywhere. It's increasing all the way from negative infinity to infinity. Where's this graph decreasing? In other words, where does it go downhill? Well, it never does. This graph just takes a little bit of a wiggle in the middle and it keeps on rising. So it's decreasing nowhere. How about positive and negative? Positive means above the x-axis. So if I kind of block everything off below, then it is positive from 0 to infinity. Remember, we don't include the 0 because 0 is not positive. Where is it negative? If I block off the top part, it's negative from negative infinity out to 0 again. So negative infinity to 0. Our next function will be the cube root function, which is y equals the cube root of x, or f of x equals the cube root of x. Now, taking the cube root of something is like the opposite or undoing the cube function. So when I looked at the keys to graphing my cubing function, where I went over 1, up 1, over 2, up 8, over 3, up 27, I'm going to be doing the opposite on the cube root. So I'm going to be going right 1, up 1, right 8, up 2, right 27, up 3. And likewise, I will be going left 1, down 1, left 8, down 2, left 27, down 3. So for my cube root, the keys to graphing are to start at 0, 0. And then we're going to reverse the order of our points from before. So we're going to go right 1, up 1, and then right 8, up 2, and then right 27, up 3. So 0, 0, right 1, up 1, right 8, up 2, and then the 27 and 3 is off of our chart. And then in the similar manner, we'll be going left 1, down 1, left 8, down 2, and left 27, down 3. So left 1, down 1, and left 8, down 2. And then this graph also kind of looks like a twisted parabola, but it's sideways. So I don't know what you want to call that. I just call mine the sideways squiggle. The domain of this function, as I go left to right, it's clear that the function covers all the territory. So it would be negative infinity to infinity. And again, don't be tricked by thinking that this function is trapped in that zone. It continues to grow and grow and grow and grow and grow. And in this side continues to fall and fall and fall. So our range is also negative infinity to infinity. Let's check for symmetry. If I fold it across the y-axis, it does not match up. If I rotate it 180 degrees about the origin, I end up with the same graph I started with. So it has origin symmetry, which means it is an odd function. Where is this graph increasing? As I travel left to right, from negative infinity to infinity, if I were on that function, I would be constantly going uphill. So this function is increasing from negative infinity to infinity, and it's decreasing nowhere. Positive and negative means above the axis, below the axis. So it is positive from 0 to infinity, not including 0, since 0 is not positive. And then it is negative, or below the x-axis, from negative infinity to 0. Again, not including 0, because 0 is not negative. So there's your cube root family.